so what we're going to do, we're going to get started on this right away so that we make sure we get through it. This is, of the rest of the stuff that we do for the rest of the year, this is probably the most important section. You're going to be doing the same stuff over and over again, or basically the same stuff over and over again. Hypothesis testing, what we're going to do for this time is large samples, so that's n is greater than or equal to 30. And this, again, the basic idea is going to be the same thing that you're going to do for the rest of the year. So hypothesis testing, this time it's for the mean. We're also going to do other, for proportions and standard deviation and variance, all that. We're going to learn two different things now. We didn't write any of this down. Two different things. We're going to talk about p-values and how you can do the test using p-values. Then we're going to also learn rejection regions. This is the one that we're going to do most of the time. Now, if you decide you want to do the other one, that's fine. But using the rejection regions is the one that I'm going to use most of the time. So don't get the whole thing is don't get the two confused. We'll go over them both today, but don't get them mixed up. Don't get things mixed up on how you do each one. Decision-based rule. We went over some of this last time. These are the two most important things here if you're using the p-values. To decide using the p-values, if your p is less than or equal to alpha, then you reject the null. If your p is greater than alpha, then you fail to reject the null.
You said don't write this stuff down, right?
No, this here I would, yeah. So that's what I was trying to see what I would use p-value. I mean, it's not that much, so might write all, but these are the two important things. This is telling you how to use your p-value once you find it. Just trying to step back so I could actually read it and see if there's anything on there I can tell you not to write down. Your p-value is going to be your area that we're going to find from your charts. Make sure you can find these charts. This is going to be real important today also. Make sure you got all those charts that I gave you. We're going to use a couple different pages in them. Every year when I teach this, I have to read back over it myself because there's again two different ways, using the rejection regions, the one that I want to use most of the time, and using the p-values to do all this stuff. And I got to read back over because they're real easy to get confused. Real easy to get things, the steps for each one mixed up. Remember your alpha is going to be, normally your alpha is going to be 0.10, 10%, 0.05, 5%, 0.01, which is 1%. Those are the alphas that we're going to use.
Did you watch the game at all?
Just a little bit.
Just a little bit of it.
Remember, alpha is your level of significance. I don't know why I didn't have that up there, but that's our alpha. That's the level of significance. So an example here, if your p-value is 0.027, so if our p is 0.0237, sorry, and our alpha is 0.05, just look at these and you decide which one's bigger and which one's smaller. This one over here this time is smaller, so we put in the less than. Well, if we put in that less than, then that tells us to, using those two rules that we're going over there, then we're going to reject the null hypothesis. So it's that simple. If it was 0.01, we put that in there, and this time the p-value is greater than that, so that tells us to fail to reject the null hypothesis. And we're going to talk about what that means as we go along through here. But that's using your p-value. Your calculator will actually calculate the p-value. We'll talk about it also as we get farther along through here. After determining the hypothesis test and the standardized test statistic, that's your z-score. I'll show you a formula for that here in a second. And test statistics corresponding area under the curve, we use a chart to find that. Do one of the following to find the p-value for left-tailed, for right-tailed, and for two-tailed. And we talked about this last time, and again, I'm going to go through this quickly. I wouldn't write any of this down. Just know you're going to find the area. You're going to use the chart, you're going to find the area. The only one that's a little different is the two-tailed. Once you find the area on the chart, since it's two-tailed, you're looking at this area and this area. Well, you find one of these areas on the chart, and what you do to get the total area is just times it by 2. So remember, left-tailed, right-tailed, two-tailed, we talked about this, and I think it's going to be in these notes here also. You look at your HA. If your HA has the less than symbol in it, then it's left-tailed. Wherever this is pointing at, that's what it's telling you. I think we wrote that down on your charts last time. If not, you might write it down in these notes. If your HA has the greater than symbol in it, sorry, that's left-tailed, then it would be a right-tailed graph. If your HA has the not equal to sign in it, then it's two-tailed.
That's what we did last time, isn't it?
Yeah, we did some of that last time.
Where you like look at the numbers and.
So if that's the case, then all we do to figure out our p-value is we find the area on the chart. We use this chart right here, and we just find the area like we've been doing for the last 3 or 4 chapters. And then that's going to be your p-value. If it happens to be two-tailed, then you find the area of 1, and you just double it, and that's your p-value. So if we do this, find the p-value for a left-tailed hypothesis. You might want to get out your charts so you can look it up, make sure I'm looking at it right. Left-tailed test, so we're on the left tail, so we look something like this. We're looking at this right here. We're looking for that area. That's going to be our p-value. With the test statistic, that's our z. That's what we're testing here. And a level significance of 0.01. To do this, and I tried to make it a little easier on you. If you look on this chart, right down here at the bottom, there's our alphas down here, and we're going to talk about that more. And it tells you your alpha, left-tailed, right-tailed, and two-tailed, and what the z's should be for each one. All right, so we're going to use that here in a little while. So on this, we're looking at this. Our z value is right here at negative 2.23. And all we do is on the chart, we find the p-value. Sorry, confused myself
Is
for a
that
second.
like your alpha then?
So your p-value is, this is where I get confused. I gotta remember what I just did. Oh, then we look at, so if this is our z, sorry, we look this up on the chart, 2.23, negative 2.23. and I go over there and it says 0.0129. That's telling us this area right here. So we use that Z value, we look that up. That's our P, 0.0129. We're comparing that to our alpha, which they told us is 0.01. And we look at this one is greater than, so that tells us to fail to reject. If this is greater than, if your P is greater than your alpha, then you fail to reject. If your P is less than your alpha, then you reject. So we use our Z-score standardized statistic that they found for us in this case. That's what confused me. So we didn't have to find it, they gave it to us. To find the area, and then that area, we just compare that area, that's our P, to whatever our alpha is, our level of significance. Find the p-value for a hypothesis test with test statistic of 2.14. So this time it's a right-tailed one. And we look at the area at we look at the Z at 2.14. That would be on the back of the page. I never turn my page because if this Z is a positive, the negative of that's going to have the same area over here. So I just look here and go 2.14, which looks like 0.0162, I think. 0.0162. Somebody else is reading their chart there. You can help me out there to make sure I'm right. That's the area right here. That's your P. Then we're going to compare that P, 0.0162, to our alpha, which is 0.05. And we look at this, and the alpha is bigger than this, so it's got to be that. And if we're saying P is less than alpha, then that tells us to reject the null. Why didn't somebody help me out?
I didn't know what you're talking about.
You guys didn't help me out and tell me it was two-tailed.
Couldn't see.
You couldn't see that.
It's not two-tailed.
It's two-tailed.
So if it's two-tailed, then what we do, once we find this P, we times it by 2. Somebody help me out, what's that times 2? I need to read the problem instead of just skimming through it.
Yeah.
Well, we just
Always
know
read
that you're right. Like also.
Always,
No,
always
that's
read
not-
your directions.
Right, and see, I don't do that. I don't read the directions.
Which one?
I have a bad problem.
0.0162 times.
Like to skin.
Huh?
Skin right there. Good for me.
Just take it twice.
0.024. Oh, no.
Right.
I forgot the six. I'm the only one doing it. So.
I already did it in my
I
head.
thought you were doing it. 0.0324. She's correct.
Now we look at this, and this number's still smaller than that, so that tells us to
Still rejection.
Reject.
reject the null. So this is what it looked like,
Two of them.
and they go through all this extra stuff that you really don't need to know. And we still come up with it being smaller, you should reject the null. So for this, again, if your p-value is less than alpha, you reject the null. If your p-value is greater than alpha, then you fail to reject the null. Those are the two key things there. this is very important. This is the formula we're gonna use to find our Z, and you're gonna have to know this because you're gonna have to find the Z each time. So write that stuff down. You have to find the Z. They're not gonna tell you the Z most of the time. On the few problems that we've done so far, they've told you the Z. You're gonna have to find the Z most of the time yourself for all the problems.
How's value look this year, Mr. Ebersole?
Not very good.
Our 3 games we've lost 2 in the bottom of the 7th and 1 in the bottom of the 9th.
We got no late pitching.
Yeah, basically. Our closer blew, Riley's there, our
Ugh.
closer blew 2 games against Bethel.
We got close.
They had him. They had him.
And Bethel's good this year, actually, they're pretty good.
Are they good?
They got a couple freshmen that are like, they could win state when they're seniors and juniors, they're that good.
Isaac domed somebody in the head.
I know, I tagged somebody, the kid,
Helmet came flying off and
well, the
everything.
kid slid, he was stealing second, and I tagged him, and it just happened, his head was there. And his helmet flew off, he got a bloody nose, that's
And
your
then,
fault.
then like another kid got hit by a pitch on the head. Matt did too. You guys had a chance for that. I would move out of the way.
So how many games did you play?
4.
Only 3.
Yeah, rugby 2.
We got beat.
They went 3-1 over break, but they didn't look that good.
Well, the sucky part is, we beat Bethel until the bottom of the 7th every game.
Yeah, they had them both games. They were up 2 in the last one. Up, I don't even know.
We're up 3.
Yeah, in the first
How
one.
do you blow a 3-run lead? No,
In
the
the
sucky
last
part is,
inning,
they
too.
didn't even get hits, it was walks, and then one kid got a hit.
That's Franklin. I follow Franklin a lot too because they have several kids on there that
Yeah, they're supposed to be good, but
they should be, but they didn't look good.
Eaton's really good this year.
Are they?
Oh, yeah.
I mean, Brady Rice, he's a junior, and they brought him in to pitch last against us, and he's set 93. Then they got Carson Brower, the one-arm kid that's curveball breaks him up this freaking much.
That's D1.
Yeah, he's going D1.
I didn't think that Brady,
Brady Diaz isn't that good.
but he's going to Wilmington for this.
They're not very good.
So the Z test that we're gonna do, again, either way, whether you're using, find the p-values or you're doing the second way that I'm gonna show you, it can be used when the population is normal and, your sigma is known, your standard deviation is known, which most of the time it's not, or the sample size is at least 30. This is what you wanna go by most of the time. Sample size larger than 30, then we use all of this. Your test statistic, for what we're doing right now is your X bar, that's the mean of your sample. Your standardized test statistic, that's what you're taking that and turning it into so that you can compare it on your graph. And this is the way we're gonna find it. This is very, very important, you gotta know how to find this. Again, the calculator will find it for you once we know everything else and once we plug everything in there for you. But it's usually easier just to find it yourself. So it goes sample mean minus population mean over the standard error, and we'll write down the formula again and a couple other slides here that'll have it in the symbols and stuff, make it a little easier. And, well, I guess right there it is. So there's the actual formula. For sigma here, you can use S. If you don't know sigma, which most of the time you won't know sigma, most of the time you'll know the standard deviation for the sample, which is just your S. And you guys might not have any trouble with this, but the trouble that I have with this formula is every time I forget which one comes first. So X bar has to come first, and then the mu, so you're doing the sample, then the population. This is gonna be what we're testing. The Z, when you calculate it, that's gonna be what we're testing each time. On this is if you're doing the p-values. So this is the list of the steps if you're doing p-values. You still gotta state your null and alternative hypothesis like we were doing before break. Number 2, identify that, they're gonna tell you that. Number 3, find your Z. Number 4, you're finding the area using the chart. That stuff's basically gonna be the same, whichever way we do it. Some of this is gonna be the same. We're gonna probably end up writing some of this down like twice, but that's the steps. Then there's 3 other steps on the next slide. But if you were gonna write any of this down, this right here would be what I would write down. And this is, again, using your p-value. If we're comparing the p-value to the alpha, this is the way we do it.
So you guys are playing us Saturday, then you gotta go play FN home?
I don't know what that deal
Yeah.
is.
I saw that, I'm like, that's crazy, they gotta drive home and play a game.
I was hoping, I
They
asked a
canceled.
couple of you guys, and
Yeah.
they didn't have any idea. I don't know what the setup is there.
They play horrible teams. They like Trombley, Rovers.
Who?
Trombley.
Trevor doesn't go.
No, they're not good.
FM.
Bradford beat them 15-0. Bradford's not that good.
I know, bro.
They'll finish 3rd or 4th.
Where you guys?
Right now, we're 1-0. We're tied for first.
The other values, or the other steps, number 5, find the area. So you're gonna find the area using the chart. Number 6, just decide whether to reject or fail to reject the null. And then number 7, you got to interpret. This is where a lot of you are gonna love this, because you gotta write like a paragraph every time. Interpret. And the way you're gonna interpret that, part of it's gonna come from the chart. So it's basically gonna be the same interpretation every time, you're just changing a little bit here and there. Number 6 is where you compare your p-value to your alpha.
Same for you guys, though.
No, actually, me and Kate pitched really good that day. I can tell it for both houses.
Well, I didn't pitch.
He pitched both games. No, Jalen did.
Well, Jalen pitched good. We just didn't hit the extra innings.
Matt did not do good.
Why didn't pitch?
Ben pitched today. Wyatt or Ben pitched. So,
You have a team?
Isn't it there?
you guys go with us?
Yeah.
Yes.
Aren't they in a conference?
Mm-hmm.
Then yeah. And we go with you guys Thursday.
We play at home.
Oh, against Shawnee. Yeah.
When you're
We just
interpreting, if you look at your charts, in your charts, you should be able to find this. You're going to use this to interpret. It's going to be like the second sentence in your paragraph. So you need to find this. We're going to use that a bunch. So we're going to flip back and forth, flip from like the front page and a couple other pages, and then find this page. And you're going to decide on here. When you're looking at this, what you're going to have to look at each time is your HO and your HA. One of them is going to be the claim. So let's say the HO was the claim. If the HO is the claim, then we look right here and we decide did we reject the null or fail to reject the null. And then this tells us what we write in our interpretation.
The claim's always the one with the greater or the equals to, right?
No, the claim is, could
Always
be
that.
either one of them. Just depends on the original problem. You gotta read it in the original problem
Oh, I remember that.
and decide which one is the claim. So you'll use this, and what we'll say is your paragraph will be split up into like 3 parts. The first part is gonna tell, it's gonna say something like with 5%, whatever our level of significance is. Then the second part is gonna be this, one of these statements.
Yeah.
And then the third part is gonna be the part that connects it to problem. So you'll have to put something in there about, you know,
Whatever the problem's about.
whatever the problem's talking about. The fisherman claims that they can catch a fish within 5 minutes,
Whatever.
something, whatever the problem happens to be about. So it's not gonna be that hard to write. It's not really a paragraph. I'm sure your English teachers wouldn't consider it a paragraph. But the first part's gonna be that, second part's gonna be one of these statements, and the third part, you connect it to the problem, and then you gotta write that every time. In an advertisement, a pizza shop claims that its mean delivery time is less than 30 minutes. A randomly selection of 36 delivery times has a sample mean of 28.5 minutes and a standard deviation of 3.5. Is there enough evidence to support the claim at a 1%? And this says use the p-value. First thing we're gonna do, we gotta write our HO and HA. This is going back to what we did before break, so if you're unsure about that, listen closely here. Your HO and your HA, it says mean delivery time is less than 30 minutes. Remember, if it's less than 30 minutes, that's gotta go in our HA, because it's just less than, and we put claim with that. What's our HO then, our null hypothesis?
It's the other way around. It's either equal to or,
If this is less than, then this has to be
Greater than or equal to.
greater than or equal to the 30.
There you go.
Alright, so you gotta write those every time. The calculator can't do this stuff for you. You gotta write the null and alternative hypothesis. This time they wanted us to use the p-values, so we'll do that. But make sure you know how to write those too. what this does. We did that right. That's the claim. So make sure you specify which one is the claim. Our alpha this time was, what was it, 0.01, 1%. We find our test statistic. Remember, your test statistic is that Z, it's X bar minus mu over your standard deviation divided by the square root of n. I got your calculator, so you can help me here. Let's see, X bar was 28.5 minus mu was 30. Remember, the mu comes from the claim, whatever the claim is. S, I think it was 3.5, but I'm going to go back just to make sure. S was 3.5, and 36 was our N. So 3.5 and square root of 36, which is just 6.
27.07. I did it all once that one.
That seems a little high. Divided by I got negative 2.57.
Yeah,
That's what I got.
yeah, I got that.
That. So that's our Z. Once we find our Z, we take our chart, we look up that number to find the area, negative 2.57. So we're on our little graph here, and you should always draw your graph. Negative 2.57. I think it says 0.0051. So that's our p-value, that's the area. We're looking right here, that's the area in that little spot right there. Then we compare that, our p-value then should be right here. See if we did all this right. Negative 2.57. Then our p-value is 0.0051. Then we compare that to our alpha, which is 0.01, and we see that 0.01 is greater than that, so that's less than there. And if it's less than, then that tells us to reject the null. Now, when we do our decision, this is, again, watch closely on this, because this is going to be the same whether we do it using the p-value or the rejection regions that we're going to go over here in a minute. You're going to write 3 parts. The first part, you're going to look at your alpha. And we're going to say with a 1% level of significance. That's our first part. Using our alpha, we just write that out. And that's going to change 1%, 5%, 10%. So with the 1% level of significance, and then we go to this chart. And we look up, we rejected the null. The HA was the claim. So we would look at reject the null, and the HA is the claim. We look at this box right here. It says there is enough evidence to support the claim. This is our second thing. With a 1% level of significance, there is enough evidence to support the claim that. And then our third part is where we go back to what the problem said. And this time it said that the mean delivery time is less than 30 minutes.
So you just like reconnect that back to whatever the problem said.
Yeah. And that's what this problem said that the pizza place says that
The
their delivery time was less than 30 minutes. So we just separate it, and you don't have to separate it. I separate it here to try to make sure that Michael can understand it. Okay, I'll write this part, this part, this part. Once you start writing it, you can write it as one big long sentence, paragraph, whatever.
Can I use the restroom real quick?
So out of what they said, out of 1% level of significance, you have sufficient evidence to conclude that the mean delivery time is less than 30 minutes. Same thing.
Check in.
We'll skip through this one. Doing the same thing, using the p-values. This one, when we read it at the end, at a 5% level of significance, there is not sufficient evidence to conclude that the mean franchise investment is different from 143,260. This is how you can find the p-value on your calculator. So you might want to write down these steps. Finding the p-value on your calculator. On the calculator, you go stat, push the stat button, go over to test, z-test. That's the very first thing. Under test is z-test. Not z-interval, not any of that other stuff that we use. Now we're doing the z-test. If you put in a list, then you want to highlight data. If you're putting in the other stuff, if they tell you the stats like a normal problem, then you're just going to highlight stats and put in the mean, standard deviation, which again is probably going to end up being S instead of sigma. The mean, that comes from the claim, whatever the claim is. Your X bar comes from your sample. And then the N is how many items there are. And if you get on your calculator and look, it'll have these three things. And they're boxed in. You have to highlight one of them and click on it. And to do that, you're going to look at your HA, your alternative hypothesis, to see which one you want to highlight. So you have to write the HA and the HO before you can use your calculator to do any of this. So if I use the pizza thing, let's see, our mu was 30, our standard deviation was 3.5, our X bar was 28.5, and our N was 36, and our it was less than, so it would be this one. So I go over that one, highlight it, hit enter. then go down to calculate. When I put all this in my calculator, it says z-test at the top. And then it says mu is less than 30. That's just telling you what your HA was to make sure you put it in there right. Then it says this, and these are the things that you can use on here. Z is negative 2.57 something. P is 0.00506 something. And then X bar, they retell you is 28.5. And N, they retell you was 36. These are the two things that we're going to use. They'll tell you, you can find the p-value by doing this instead of looking it up on the chart, finding that area on the chart. And they also tell you the z-value that you had to find anyway. So instead of using that formula to find z, we could have used the calculator. So this is to find the p-value. You could also use it to find your z. I don't like to use the calculator to find this stuff because there's a lot of buttons to push and to stick stuff in there. Maybe Lily doesn't want to calculate z, so if she wants to use this, that's fine. You guys might be a little better on your calculators than I am. I would rather just, you gotta use the calculator to find z anyway to punch it all in. So maybe it's better to just stick this stuff in there and find z that way. But when we get to the way that I want you to do this with the rejection regions, you still gotta find z. All right, rejection regions and critical values. Again, this is the second way to do it. Put some of this on here, see what I want you to actually write down. Oops, previous. So just write rejection regions. We're going to talk about how to do it. Rejection regions. The range of values for which the null hypothesis is not probable. So again, we're looking at our curve and we're finding a rejection region here. And if our test statistic falls in that rejection region, then we're saying, hey, it's not probable that it should fall in that rejection region, so something's wrong here. Our rejection critical values, that's going to be our ZO. You could have left-tailed, you could have a right-tailed, where it looks like this, and that's your ZO right there. Or you could have a two-tailed. My drawings aren't the greatest. So you're going to have a negative ZO and a positive ZO. Two critical values there. And all we're going to do is we're going to find a number, and we're going to decide, does it fall in that region? And you're just going to look at it. You're going to know what this number is, and you're going to say, okay, where does the number, the test statistic that we found fall? Does it fall in the shaded region or in the white region? If you're using your calculator, you can't use your calculator to do it all, but all that stuff that we just wrote down a minute ago, you can use your calculator to find your Z. So we just wrote that down, but you can use the calculator to find the Z, but you still have to do all this other stuff. You still have to write out your HO, your HA, and everything else. This, I think I have this on here twice, and I'm going to sort of skip through this. Specify, don't write this down because I think it's easier with what I got written somewhere else. specify the level of significance, decide whether it's left-tailed, right-tailed, or two-tailed, find your critical values, find your ZO, sketch the standardized. You gotta make sure you're drawing these graphs on each one, and deciding, hey, I'm here, if it's left-tailed or right-tailed or whatever. So draw it each time. This chart is right here on the front, on the bottom of your charts. Make sure. Is that on your guys' charts? On the front page? I don't remember which one I printed off for you. Is it on there? So this is telling you your alpha, left-tailed, right-tailed, and two-tailed, so you don't have to look up all this stuff, and you don't have to worry about multiplying by 2, dividing by 2, and all that stuff, because it just tells you right here. If you're 10% and it's left-tailed, that's your critical value. Right-tailed, two-tailed, then you got a positive one and a negative one. So if I was at 10% and I'm two-tailed, then I'm like this. Got these two areas, those are our rejection regions. This one is a negative 1.645, and this one's a positive 1.645. Then we're gonna find our test statistic, and we're gonna decide, you know, if it falls in there, if it falls in here, if it falls in there, and that tells us whether to reject or fail to reject the null. So that chart's right there on the front. We're gonna use it a bunch. So if we're at, find the critical value in the rejection region, if we're two-tailed at 0.05, just look right here, two-tailed for 0.05, and we're gonna draw this little chart. For two-tailed, and right here it tells us number, this is a negative 1.96, that's a positive 1.96. That's all we're doing for that part. This is showing you the wrong way to do it. I made the chart there for you so you don't have to do all that. It's taking 1 minus the alpha, it gives you 0.95, so you want 95% of the area in here, you want half of the rest of it there, half of the rest of it there. This is telling you the numbers. You don't have to worry about doing all this stuff because I've done it for you. I don't see any reason to do that every time. If you can just look at this chart and get the numbers that you need here, your two critical values. So again, all you're gonna do, you're gonna find that. You're gonna find your critical values there, if there's 1 or 2 of them, and then decide, is your standardized test statistic in those rejection regions? This is what I would write down if you're gonna write down anything in the steps how to do this. Give me a second to get these up here. So the first thing, when you're doing this, first thing you gotta do, state your null and alternative hypothesis. Number 2, figure out what your alpha is. Number 3, you're gonna use this little chart, and I'll write little chart there. You're gonna use the little chart to figure out your critical values and to determine your rejection regions. Oops, sorry. Number 3 should be that. Number 4 and 5 is that. That too confusing, Michael? So you gotta sketch your sample. Well, that's real hard. You're gonna sketch that each time. Then you're gonna figure out your critical values from this little chart. I'm not sure why. I guess I must have thought you guys were completely and totally stupid or something, because these two are basically the same thing. You're gonna find your critical values and shade the stuff in there.
Mr. Ebersole, Mr. Rocha.
Sir?
Number 6, you're going to find your Z. That's what we're testing. To find Z, you might use your calculator if you want. That's up to you if you want to use your calculator and find Z that way, or you could just plug into that formula. Number 7, when you look at your rejection regions, once you find Z, let's say this is our rejection region, and we find Z, if Z falls in that area, then we reject the null. If Z falls in this area, then we fail to reject the null. Then number 8, we write out the paragraph with our paragraph here for number 8. Part 1, remember you use your percent. Part 2, use the statement from the chart. And part 3, you connect it to the original problem. So those 8 steps, that's what we're going to be doing, and that's basically what we're going to be doing for the rest of the year on all this stuff. It's going to change a little bit just because we're not always going to be doing mean and all that stuff. So we may be doing proportions, we may be doing standard deviation, whatever. So an example here, employees in a large accounting firm claim that the mean salary of the firm's accountants is less than that of its competitors. So you got people that work at this accounting firm and they're throwing a fit because they're getting paid less than people at other accounting firms. Which is $45,000. A random sample of 30 of the firm's accountants has a mean salary of $43,500 with a standard deviation of $5,200. At a 5% level of significance, test the employee's claims. So I'm going to write some of this over here before we switch to the next slide. Have your calculator out so you can help me find the Z here in a minute. So we know our N is 30. When we go to write our HO and our HA, you're going to have to do this stuff every single time. Your HO, HA, it says employees of a large accounting firm, mean salary is less than the competitors, which is this. So that's going to be our HA. That's the claim.
That means the other one is greater than or equal to 45,000.
Greater than or equal to 45,000. So that's our HO, that's our HA. We know which one's the claim. That's the main start. When we take a test over this stuff, that right there will be worth like 3 points. Then the problem will go on. Our alpha is 0.05, and our standard deviation is 5,200. Next thing we want to do, I'm going to draw my little graph next. Terrible graph, but we look here. That tells us that we're left-tailed. We shade that in. You grab your chart. Our level of significance is 5%, and we're left-tailed. So we look at this chart, 5% left-tailed. Tells us negative 1.645. We write that right there. So that's what our chart looks like, our little bell curve. Next thing we do is we find our Z. That's X bar minus mu, which X bar this time is 43,500. Mu is 45,000 over S divided by the square root of N, which is 30. We find that. I know the top is negative 1,500. Do that in my head probably. So then I'm just going to take 5,200 divided by the square root of 30. And I get 949.38 something.
Yep.
Take negative 1,500 and divide by, and you guys could probably do this easier, I probably should have done it a different way. I'm gonna divide by that number right there, 949.3857663, and I get Z equals negative 1.58. This is what we're testing. So remember, zero's right here. I look over here and I gotta figure out where that falls in relationship to that line right there. Is it gonna be in the shaded part or is it gonna be in the white part? Well, you look at the two numbers, where does this fall in relationship to that? Is it in the black part or the white part?
Should be black.
White
No, wait.
It's sort of difficult when you're dealing with negatives, right?
Yeah, so hold on. It'd be in the white part.
It'd fall like somewhere right here,
Right
wouldn't it?
next to the line.
So if it falls in there,
Yeah.
if it falls in there, then that tells us to fail to reject the null. So we make that decision, once we decide fail to reject the null, then we gotta write our paragraph. First thing I'm gonna write, number one is, we were at a, what was it, 5%, alpha was 5%. So at a 5% level of significance, then we look at this chart. When you look at this chart, our HA was our claim. So the claim was the HA, that's this column. And we failed to reject the null, so that's his bottom one, so we're looking at this box right here. There, be careful when you're writing these because they all sort of say the same thing. There is not enough evidence to support the claim. This is part one. This was part two, and I'm going to start part three right here just to make it look more like a sentence. The claim that the competitors, let's see, competitors' salaries are more than the companies. So we write it out just that way. Hopefully I did it all right. We'll see here in a second. Our HO, HA, is that? This one should say claim, unless I got it up there again. No, this one should be the claim. draw our little picture. That's our rejection region. Found that on our little chart, negative 1.645. We found our Z, it was negative 1.58. We're testing that, seeing where it falls at in here. Negative 1.58, they show you right here, it falls somewhere about in there. So it falls in the unshaded region, so that tells us to fail to reject the null. Falls in the shaded region, we reject the null. At a 5% level of significance, there is not enough evidence to support the employee's claim that the mean salary is less than $45,000. Trinity, think you can handle all that? Too much English?
Too much English.
Oops, let's go back. If we found our Z-score, again, you could find your Z-score by putting these numbers into the calculator. If we found that, we look over here. That falls in the rejection regions, so that would tell us to reject the null. And then we look up on the chart and we write it out. That's your assignment. The first part deals with the p-value stuff. So using the p-value. Then the second part deals with the rejection regions. When you get to the word problems, if you want to do the rejection regions and not the p-values, because that's what we're going to be doing most of the time, I don't have any problem with that.